Hello everyone, my name is Nicola Aryandi Putra, and here I am in this video gonna explain about economic maths. The topic that I will talk about is nonlinear equations. Nonlinear equations has three different members. The first one is quadratic functions, the second one is exponential functions, and the third one, the last one, is logarithm and natural logarithm function. But before it, I will explain what is linear. Linear itself means something that related to line. Nonlinear equations can be interpreted as a non-condition equations such as linear equations. So nonlinear equations that have a rank other than 1, for example like x to the power of 2, and equations that have a product of two variables, example like x and y. So we begin on the first function is quadratic function. Quadratic function is a function with a variable of degree 2 that expressed in y equal fx equal ax2 plus bx plus c form, where the a, b, and c is the real numbers and a must not be 0. And here's the example of the quadratic function. Here's the answer too. And here's what the graphic will look like. The graphic function of the quadratic function, it was like parabolic shape like that. Let's move to the second one. It's the exponential function. Exponential function is a function that maps every x real number to the a to the power of x form. So the exponential function has changed into fx equal ax form. With the a more than 0, a must not be 0, and x are r. Exponential function also a function whose variable is the rank of number of a constant. For example, it was like y equals ax, then x and y are variables and it's constant. And here's the example of exponential functions. There's an answer, there's a questions. And here's the graphics look like. Let's move to the last members. The last functions is logarithm. Logarithm is an opposite or inverse of the exponent, which expressed in. As you can see the formula on the picture, the a is known as abscissa, the x is known as numeric. Logarithms graphic. In graphing logarithmic functions, the values of a must more than o and a must not be 1, must be split into two values, so that by doing point counting, the general form of the logarithmic function graph will be obtained as follows. First one, both graphs should be symmetric of x-axis. Both graphs should be intersect on the x-axis at point, for example, 1 and 0. Both graphs are asymptotes on the y-axis. And here's the example of logarithm. And here's the answer too. I think that is all for my explanation. Thank you and sorry for the misleading or wrong explanation. Thank you.